Welcome to Mr. Chalk's Revision Tips. In this video, we will look at
resultant force and calculating resultant force. So an object may have several different forces acting on it which can have different strengths and directions, but they can be added together to give the resultant force. So this is a single force that has the same effect on the object as all the individual forces acting together. So if we've got two forces from the same direction, so two forces that act in the same direction produce a resultant force that is larger than either individual force alone. So this can be calculated by adding the two forces together. So in this example, if we've got 10 and 5, that will give us a resultant force of 15. We can have two forces acting in opposite directions. So the two forces that act in opposite directions produce a resultant force that is smaller than each individual force. So to find a resultant force, you subtract the magnitude of the small one from the larger one. So the direction of the resultant force is the same as the direction of the larger force. So if we've got a zero resultant force, so when the forces are balanced, there are a resultant force of zero. So in this case, a stationary object remains stationary, or a moving object keeps moving at the same speed and in the same direction. So for example, in the force diagram for a weightlifter, the arrows are the same length. As they're the same size and in opposite directions, the resultant force on the bar is zero. Its weight acting downwards is balanced by the upward force provided by the weightlifter. So this means that if the bar was already still, it would not start to move. If the bar was already moving, it would continue to move at the same speed and in the same direction. So when all the forces are not balanced, the resultant force is not zero. So in this case, an object accelerates in the direction of the resultant force. So this means that a stationary object begins to move in the direction of the resultant force, or a moving object speeds up, slows down, or changes direction depending on the direction of the resultant force. So in this diagram of the weightlifter, the resultant force on the bar is not zero. The upward force is bigger than the downward force, so the resultant force acts in an upwards direction. So there are three possibilities. The bar will, the bar was still to begin with and moves upwards. The bar was already moving upwards and continues to move upwards faster. Or the bar was already moving downwards and so moves downwards more slowly than before. So note that you cannot tell which possibility is correct unless you know if the bar was already moving. So in this next diagram of the weightlifter, the resultant force of the bar again is not zero. So the upwards force is smaller than the downwards force. So the resultant force acts in a downwards direction. So again, there are three possibilities. The bar was still to begin with and moves downwards. The bar was already moving downwards and moves downwards faster. Or the bar was already moving upwards and so moves upwards more slowly than before. So if we look at a few examples, in this first example, if we're working out the resultant force, you would add the two forces together, which would give you a resultant force of 15 newtons. Same again with the second one, you would add the forces together to give you a resultant force of 40 newtons. Bear in mind that the direction of the arrow is showing the direction that the force would be moving. If you have forces in the opposite direction, you would subtract the smaller one from the larger one. So that would give you 7 newtons going to the right. And same again, the resultant force of this final one would be 46 minus 23, which would give you a resultant force of 23 newtons going to the left.
Thanks for watching.